So let's talk about the next piece. We are going to start graphing our polynomials today. We have really done all the components of this. For the most part, we've talked about each piece, but now we're going to put it all together to draw a graph. So the steps for graphing are listed here. On a test or quiz, I wouldn't just say graph it and expect you to list all 6 steps. I would break it down and say part A, tell me the degree. Part B, tell me the end behavior. So I would prompt you on each piece. We know the degree is what? Your highest exponent. And we need that degree so we can decide the end behavior. We know even powers look like parabolas, odd powers look like chairs. Zeros, that's just another word for the x-intercepts. Okay, we are finding zeros yesterday and last week, so we should know how to do that. When we have those are the places we hit the x-axis. Then we will decide if our graph will go through or bounce at each of those zeros. It's been a while. We talked about it early last week. This is based off the multiplicity. An odd multiplicity does what? It goes through, and an even multiplicity will bounce. How do we find a y-intercept? What is a y-intercept? What does that mean? Well, zeros are your x-intercepts. So an x-intercept is when y equals 0. A y-intercept is when x is 0. And that'll show us where we hit the x-axis, or the y-axis. And then we're going to put that all together on a graph. For these graphs, like I have you find all this information for a reason. So I'm not just asking you to list all this stuff and then like scribble something down on the graph. Everything we find, we need to make sure that we are plotting on our graph. And that's what I will be looking for. So today we're just going to practice this part. Have what they need from this. So if I ask you to graph this, we are going to go through our steps. So what was the first step we wrote down? Degree. Okay, the degree. It's saying if we multiply this out, we would have x to what power? You have 2x times x times x, so it's x to the third. So my degree is 3. Second thing I need, end behavior. Okay, this is a 2x cubed when we multiply it all out. We know odd powers look like a chair. It's a positive 2 in front, so does it flip? No. So it's just down, up. So that's the end behavior we were doing last week. Then we do our zeros. Okay, that's, if it's factored, it's just what makes each parenthesis equal 0. What makes 2x minus 1 equal 0? 1 over 2. What makes x plus 1 equal 0? What makes x plus 3 equal 0? Right, do any of these have a multiplicity? No. Multiplicities would be like if I had a square or a cubed up there. These don't, so it's just a multiplicity of 1. We don't have to write it. Then we have to go decide, will the graph go through or bounce at each of these? That is based off the multiplicity. All of these have a multiplicity of 1. 1 is an odd number, so what will it do? It'll go through all. Okay, number 5, we need to find our y-intercept. So to do that, we plug a 0 in for x in the original. So 2 times 0 minus 1 is negative 1. 0 plus 1 is 1. 0 plus 3 is 3. -1 times 1 times 3 is -3. And then we draw our graph. Okay, so when I look at this, my end behavior is down up, so I know my graph should start down here and end up here. Zeros, that's where I hit the x-axis. So at positive 1/2, -1, and -3. My y-intercept is -3. So I hit my y-axis at -3. So I plot my zeros and my y-intercept. Now we draw the graph. This graph is a curve, so there's no zigzag, there's no breaks in the graph. It's just a curve that bounces back and forth. We know it has to start down here. I have to come up and hit the x-axis here. Now once I hit the x-axis, what do we say our graph's going to do? Bounce or go through? Go through. So it's just going to come up, come back, and hit this one. And we said it goes through. So then I have to hit my y-intercept. Come back, hit this one, goes through, and it ends pointing up, like we said. So notice, the only places my graph touched the x-axis were the zeros. The only place my graph touches the y-axis is my y-intercept. And our final graph should match the correct end behavior. Now, is this graph perfect? No. For all I know, the middle part, maybe it went up really high and came back down, okay? Or this could have gone down and then swooped back up. I don't know all the ins and outs. We could get more points if we needed that information. What I'm looking for on your graphs, do you have the correct x and y intercepts, correct in behavior, and is it curved? A nice curve, not a zigzag, okay? Any questions there? Okay. Let's keep practicing. What is my degree, my highest power? My end behavior, we have a positive x to the fourth, so what's the end behavior? Like a parabola. Okay, our zeros. All right, this is a little bit harder because it's not factor. We can factor them if I give you the first zero. That's what we were doing yesterday, but I didn't even give you the first zero. Is there any other way we could factor this? Grouping. We can take an x cubed out of that one. Take an 8 out of this one. What makes x minus 2 equal 0? Okay, if I set x cubed plus 8 equal to 0, what do we get? Since it's a negative, or a cube root of a negative, we actually do get an answer. It's just -2. All right, technically it's an x to the fourth. There should be 4 zeros. The other two are imaginary here. Can we graph an imaginary zero? No, so I'm not going to worry about it today. We will talk more later in the week about how we could find those in this scenario. So to decide if it goes through or bounces. Both of these have a multiplicity of 1. 1 is odd, so what will it do? Through both of them. How do we find the y-intercept? Put in 0 for all of our x's. Pretty easy to do if you look back at the original. You get 0 minus 0 plus 0 minus 16. We're going to draw our graph, plot our x and y intercepts. So I hit the x-axis at positive and negative 2. My y-axis at negative 16. Sometimes you're going to get a really big y-intercept. You don't have to count by ones. I'm just going to count by 4s. Okay, we said that both ends should be pointing up. So it's starting up here. We hit our intercept, and we said our graph goes through it, so it's just going to keep going. I hit my y-intercept, keep going, come back and hit this one, keep going. So something like this. Now is this perfect? Absolutely not. This end looks a little funky, but I'm looking for the correct placement of your intercepts and if your graph is curved appropriately. Is that one okay? I'm going to put one up. I want you guys to see if you can list out the information. Okay. In behavior, x cubed is down up, but we have a negative 2 in front, so it will flip. So it's up down. All right, what did you have to do to get your zeros? Yes. Probably pulled out a greatest common factor first. And if you want, you could even take out a negative x, so that leading term is positive. So then if you do your slip and slide, divide our 2 back. So we have the negative x I took out, x plus 1, 2x minus 1. Okay, it was x to the third, so there should be 3 zeros. What makes just negative x equal 0? 0. What makes x plus 1 equal 0? Negative 1. What makes 2x minus 1 equal 0? 1/2. Okay, none of these were squared, so the multiplicity is 1. 1 is odd, so it will go through all of them. Y-intercept, if you plug in 0 for all of your x's, you can do it in the original or the factored. What do you get? 0. Okay. So I hit the axis at 0, negative 1, positive 1/2. Y-intercept at 0. Should start up here and down here going through all of them. So hit this and go through, that one go through, this one go through. So it should look like that overall. So far, so good? All the problems we've done so far, the multiplicities have been 1. Let's do some that aren't 1 and make sure we know how to handle that. So let's say I gave you this one. X minus 1 squared times x plus 2 cubed. My degree, if I multiply this out, you have an x squared times an x cubed, so overall it's x to the fifth. In behavior, 5 is odd, so it looks like a chair. There's not a negative to flip it, so it's just down, up. Zeros. It's already factored, so that's easier to find. What makes x minus 1 equal 0? Positive 1. But that was squared, so it's multiplicity 2. X plus 2, what makes that equal 0? Negative 2, but it was to the third, so that's multiplicity 3. So to decide through or bounce, remember, it's the multiplicity. 2 is even, so what's the 1 going to do? That one will bounce. Okay, over here, the multiplicity of 3. 3 is odd, so that one will go 3. So we're going to bounce at 1, go through negative 2. Y-intercept, if I put in 0 for all of my x's, I get negative 1 squared times 2 cubed, so 1 times 8 is 8. All right, so my graph should start down at the bottom, end up at the top, hit my x-axis, negative 2, positive 1, y-axis at 8. If you want to count by something other than 1, just make sure you're labeling. Okay. So my graph starts down here. At negative 2, it goes through, so it's just going to keep going, come back, hit your y-axis. What happens at 1? It bounces. That means I touch the axis and come back up. So it looks like this. Is that one okay? Last one, and I'll let you guys start your homework. Okay, my degree. If I multiply this out, I have an x to the 5th times an x to the 4th. So overall, that's x to the 10. So degree is 10. There's not a negative in front, so it's not flipping. 10 is even, so it's like a parabola. So both ends are pointing up. Zeros. If you have a plain x, what makes that equal 0? 0, but it was to the 5th power, so the multiplicity is 5. Okay, x minus 3, that would just be 3. There was no exponent. X plus 4, that would be... Okay, so is 0 going to go through or bounce? Okay, what about 3? What about negative 4? Y-intercept. If I put in 0 for all my x's, I get 0 times negative 3 times 4 to the 4th. 0 times anything is 0. Alright, so I'm hitting the axis. 0, 3, 4. Both ends are pointing up. Okay, so I'm going to come down. What happens at negative 4? Bounce. So I'm going to hit it and come back up. I have to hit at my next point at 0. That one went through. I have to hit at my next point 3. That one went through. So it keeps going up. Okay, how do we feel with it? There is a handout posted on Classroom. But I'm not going to have you do all of them. Oh, bless you. I want you to do questions 1 through 3, 7, and 8. Please list out the information like we have been doing. Don't just try to draw the graph. Go ahead and list those pieces like we were doing.